Thanks, everyone. Great to be up here. Excited. I've been presenting in all over the place. The kind of weirdest place I've talked to is Kazakhstan, but I live in Utrecht, and I've never spoken in Utrecht or the Netherlands before. So I'm very happy to be speaking here for the first time. I want to talk today about open source tools and kind of securing the stack. And how we can do that. So if you're wondering where I'm from, where my accents, I'm from Aotearoa or New Zealand. I live here in the Netherlands and I work for a Belgian company called Aikido Security. You probably haven't seen us. We have a very small banner somewhere out there that is well hidden. And you can find me anywhere under the socials of Advocate Mac. Okay, so I think one of the first kind of questions a lot of people ask when they're looking for a security tool is, why the heck are security tools so gosh darn expensive? And I think it's a theme that we see everywhere, where security tools are kind of exceptionally expensive from this. But a lot of people don't actually realize that there is a very fundamental reason that creates this. And it's one that I think a lot of people kind of agree with, and that is that Formula One teams are very, very expensive to run. And if you don't know, all the Formula One teams are sponsored by cybersecurity companies, right? And by proxy, if you purchase these tools, I guess in some way you are helping sponsor these Formula One teams. So we're in the land of Max Verstappen here, so we all thank you for your contributions for that. But of course, a little bit being facetious, but there are other options out there, and hopefully by the end of this talk, I want to say that there are solid reasons for choosing open source. There are also solid reasons for choosing commercial, but you don't have to sacrifice security if you do want to go down an open source route. So why choose open source? Obviously, there's the cost factor to this. Now, open source aren't necessarily always free because they do cost a lot in engineering time down the road, but that initial investment is low. They're community driven. You have flexibility in it. You can look under the hood. And also, they're great for a proof of concept. And what I mean by that is if you're struggling to get funding, if you're struggling to get onboarding or uptake on getting security tools into the system, then open source tools are a great way to prove the problem that we have and prove that there are issues, and you can show some scary reports from them at a low cost that at least gets you to either invest in helping building out those tools internally or to invest in other solutions as well. Of course, there's some cons that come with this. Maintenance, there's no support. There's limited features kind of post-detection. I'll talk a little bit more about that. And of course, like engineering time. So the real choice of it comes, build versus buy. When you're building out and you're choosing open source tools, there's going to be some time in there to build them to fit into your stack, to fit into your workflow, and to make sure that they're working well. So before I go too further, I do want to kind of address one thing that's a bit of an oxymoron, is that I come with a security vendor, Aikido. We're more than happy to sell you expensive security tools at the same time. So why on earth would I want to encourage you to choose open source? Essentially, just to say the kind of quiet part out loud, is that Aikido is actually built a lot upon open source. And we're really proud of that, and we're unique because we also admit it, unlike other people. But open source provides a great foundation, and when we build out new features and when we build out new detections, we also open source them for the community. And there's a little bit of a benefit for us too, in that if you're looking for a commercial tool and you've already been down the open source route, then you're a well-qualified customer, a well-qualified prospect, as we could say. And if open source tools meet your need and you're excited by that and you can invest it, then we don't want you as a customer, because we're not going to add the value from that. So this is kind of a little bit of why we would encourage you to go down that open source route. We're very proud of it. We like to support the open source community. And if open source works for you, then by all means, that's a route that you should at least explore. So this will be all that I'll mention from Aikido for the rest of the talk, in case you're wondering when the pitch is going to come. So today I want to talk about kind of three things, like what do we need to protect? So what tools do we actually need? And then we're going to look at what are the attackers targeting. So do I really need to secure this? What is the risk it takes for me? And then what tools can we actually implement to be able to protect our systems? Now, I'm going to mention a whole bunch of tools. I'll do some very quick demos just to kind of give an insight into some of them. There's lots out there. You don't need to pick the ones that I've chosen. These are just ones that I know about, that I use. There's plenty of great ones out there that you can look into, and different ones are going to meet your needs. So what do you need to be secure? When you're trying to build out, you're starting from zero, what do I need to secure in my applications? What are the systems? What tools do I need? And there's a whole bunch of acronyms and everything, but if you break it up, it can be overwhelming. But if you start with what's critical, the first one there, CSPM, Cloud Security Posture Management. This is basically securing our cloud infrastructure. Secrets detection, in-app firewalls, and software composition analysis. These are what I consider critical. And they're critical a lot because you can target and get rid of a huge amount of attack vectors with these four coming in there. Next, you kind of want to look at what is going to be a priority from that. Infrastructure as code scanning, malware detection, SAST, static application security testing, dynamic application security testing. I know some of you will probably fight me on the importance of all of this. That may be different for everyone. These are what I have, and particularly the reason why the critical gets critical is because a lot of that can get rid of the low-hanging fruit for attackers in your systems. And then if you want to kind of continue out building your maturity, license protection and end-of-life components are also some great tools that you need to think. Now, when you look at this and you think about, oh my God, I got so much stuff to implement, this is going to take me so long to do, it can be easier to think about it as what do you actually need to protect? Because trying to secure everything is overwhelming. So you want to protect your dependencies, your software supply chain, we'll talk about this. You want to protect your source code. This probably means something different than what most people. And you want to protect your cloud infrastructure and your runtime, your application when it's actually functioning. And if you kind of focus on these four things and start just on what's critical and for you, whether or not you agree with me or not, you can come up with your own tools. Then all of a sudden it kind of starts to become a little bit more manageable and you can go down your process of kind of open source tooling. So I want to start with securing the open source supply chain. This is probably a figure that has come about because people like me love to talk about it. And that is that 85% of your application source code doesn't actually come from you. It comes from all the open source tools that you need. We probably, as I said, a lot of you have probably heard by this. But what does it actually mean for those of you that maybe don't know? You have your application. Your application has a bunch of open source dependencies that do specific things. And it also has dependencies for your dependencies, and then they also have dependencies for the dependencies of the dependencies. These are called transitive dependencies, and it goes down for a long way. And then we also have kind of third-party systems that we do. So this is what we call our supply chain, and our open source supply chain is what's on the left there. Now, this is a very clear message. We can all understand exactly what's going on. We have our open source, we have our third-party, everything separate. It's very nice. But in reality, it looks a little bit more like this, because everything's dependent on each other. You have open source dependencies that are dependent on each other. You have third-party dependencies that are dependent on open source dependencies. So even just trying to understand what your risk is really, really difficult. And so when you have something like this one here that's all the way downstream, let's just call this box a random name. Let's call it log4j. And all of a sudden that can affect your third parties and then your application, and you kind of haven't done anything wrong. You didn't even know that you were vulnerable to it, but it happens. And this is why it's important to understand what's happening in our open source supply chain with our dependencies and that we're able to protect it. So what are the attack paths that people can make to try and target our open source supply chain? So the first one is targeting known vulnerabilities. So when open source tools have vulnerabilities in them, they're typically disclosed in databases like NVD or CVE, and they get assigned a number, like a CVE number, and attackers and defenders both know that that component's vulnerable. So a common path is to try and attack known vulnerabilities in systems. There's also something called dependency poisoning. Now, this is when you make a concerted effort to try and take over an open source project and poison it with malware. People go to great lengths to do this. And also something called typo squatting, which is not very sophisticated. It's when you're relying on developers and the fact that they can't spell very well, which sometimes is more true than others. With me, it's very true. So what's kind of like an example of this? I mentioned Log4j. So targeting known vulnerabilities, Log4j is probably the most well-known vulnerability on the planet. It's kind of caused catastrophic impact. It was the worst Christmas for every single person in security that year when it happened. But in 2023, 30% of applications that were dependent on this were still running a vulnerable version from it, which is, to me, just seems absolutely insane. And that means that attackers can target these vulnerabilities, these holes as well. Dependency poisoning, something like the XZ Utilis that happened recently. This was a compression software that was in core Linux that someone spent 2 years trying to take over the project, successfully took it over just to inject malware into it and almost brought down the entire internet. We really missed out by that one from a year. And something like typo squatting would be something like CCXT, which someone created a malicious counterpart for called CCTX, relying on people to try and misspell that. Yeah?
For typo squatting, it's not just spelling typing errors. Like, for example, in the Python PyPy, there was a famous library called requests, and they typo squatted request2, so it looked like the successor to it. So it's not just developers who are bad spellers. There's some really legit cases of typo squatting that's not spelling error.
Yes, I mean, absolutely. And there's also dependency confusion, if you want to kind of take it to the next step. There's like, I guess I'm kind of just trying to to keep it simple, but you're absolutely right. There's lots of ways where we can kind of get more sophisticated in this. And, to kind of stick to open source dependencies, this is one of the most popular memes on the internet. It's shared at most conferences. I can't help but share it myself because this is so accurate. And it's when we have this kind of infrastructure that we have where everything's kind of pinned up on this one random project that someone's been thanklessly maintaining. But this is so true that we can actually put a name to that person. So there's a guy called Vishal who runs this project called UA Parser, and Vishal represents one of those people that are legends that maintain open source stuff without great thanks. And why is this significant? Well, if we look at it, this is a very popular project, 10 million weekly downloads, 56 versions. This would pass anyone's smell check for trying to find a solid open source dependency. But what we also found is that on a Russian hacking site, then someone posted this and say that they're selling an account on NPM, which was the package manager, and there's no two-factor authentication on the account, and that you can change the password and you can inject malware. And we can kind of figure out what happened. Vishal's account got hacked, and they injected malware onto UA Parser. So even though no one's done anything wrong in that scenario, mistakes happen. You've implemented a legitimate and high-quality dependency, but it's been turned malicious. And so this can absolutely happen. So if we look at these attack paths, how do we avoid them? What are some of the tools that we can use? So SCA, software composition analysis, is one of the absolute best ones and ones that we can use. We can also look at malware detection, and we can also look at end-of-life components. So SCA will look at your open source supply chain. Good SCA tools will look not just at the top layer, but at multiple layers down, and they discover if there's any vulnerabilities that have been there. When it comes to dependency poisoning, SCA tools work well, but only after that's been discovered. And so then you need something called malware detection, which can detect malware inside those. So it will detect things that haven't been reported. And then end-of-life components, this is a great way to detect something that's a high candidate for being poisoned over time. Something that's no longer actively being maintained, because there's a lot of people that look for that when they're trying to find it. So if you want to have a look at some open source tooling that we have, SCA has some great ones. Dependency Check, Dependency Track, and Trivy are 3 great open source tools. Malware detection, this one's kind of what I call open source-ish, because it does have an open source component to it, but it also requires an API key with Pylum. There we are. And end-of-life date is a good database for detecting when components have started to run out or not be actively maintained. And then license scanning is another one. This is more for compliance, but you can use a great tool called Sift for that. And then we can have a very quick demo on what some of these would look like. if we want to look at Trivy, I have a project that has a bunch of vulnerable components for it, and we can just run a scan, and this scan, are we working? Well, okay, it was running. And so here you can see it looks in our project, it looks in the documents that we have, like your package.json files, for example, to find out are any of these components kind of vulnerable, and we can see that we have multiple in here that are what we call critical or high, that have CVEs against it. So these are the kind of simple tools. They can get more and more complicated, and they can add lots and lots of features, and even a lot of open source ones have great features to be able to kind of help you maintain this and be aware when these go out of date for it. All right, so moving along, we've looked at our open source supply chain. Now I want to look at securing our source code. And when a lot of people, when I say this, they kind of think that I'm going to talk about SAST, Static Application Security Testing, but I'm actually not. I'm going to talk about your source code in and of itself, because your source code is a very low-hanging fruit for attackers, where it is very leaky, but it contains lots of sensitive information. So what's inside our source code? The main threat are secrets. Secrets are everywhere in our source code. And I'll talk a little about that. We also have PII, and you also have some business logic. The next two are kind of a little bit of concern. PII shouldn't be in your source code, but it often ends up does. Business logic, yeah, this can help an attacker, but the main one we want to talk about are secrets. And secrets are absolutely everywhere. So you're going to expose secrets when our source code is made public. For example, T-Connect was a mobile application from Toyota. A contractor leaked some source code in their personal GitHub repository that had the keys in it to a database, which caused a massive data breach. And then we can also have these keys in our private source code. And private source code is terrible at staying private. So if we look at kind of the news headlines, massive companies that I would consider to have great security posture, like Microsoft, have all had their source code leaked out in public in various methods. Sometimes it's from a misconfiguration, sometimes it's from a disgruntled employee, sometimes it's from a malicious attacker that's gained access to it. And we can, thanks to Twitch, who had their source code involuntarily open sourced, we can actually have a look at how many secrets we can kind of typically see inside this. So Twitch had 6,000 Git repositories that were leaked, 3 million documents, and over 6,600 secrets were actually exposed in this. Now, before anyone from Twitch gets mad at me, I just want to say that this is actually remarkable. This is incredibly low from what you'd see in a standard. To have only 6,000 secrets exposed is actually really good. And I'm not being facetious. That is actually true. But good still means you have 194 active AWS keys in your source code when it's leaked, right? So this was a very bad day for the engineers. So we know that source code contains lots of these secrets. And secrets, like API keys, passwords, credentials, they're very high-value targets for attackers because they can quickly elevate privileges and move into different systems. You don't need to have any high level of sophistication to use secrets to move laterally into areas. Now, other areas is, okay, how does this kind of happen? Well, Cyber News did a research study that exposed a big problem of .git directories. So when you create a Git directory, you go git init, it creates a little folder called .git. Inside that .git folder is all of your metadata, it's all your sensitive stuff, it's all your history. And that often gets leaked. So Cyber News did some wide-scale scanning. They found 2 million of these .git directories that were on publicly accessible, and they didn't download all of them. That would be considered illegal, but I can tell you from experience that I'm certain that there will be a treasure trove of sensitive information inside of these. So it's very easy for source code to accidentally end up there in public, even when it's intentionally made to be private. Now, I have a funny story here, just to kind of show how easy it is for everyone's source code to end up being public. I have a buddy called Philippe Cartrel, and Philippe is a pen tester, and he had an assignment for a certain company. So what Philippe did is he bought the domain name gitlhub.com to try and kind of create mass GitHub. And getlhub.com was a mirror of GitHub. And Philippe used that to send a phishing campaign to the developers. This is very common because if you can get access into a GitHub account, this is fantastic. And right now is the part of the story where you all expect me to say that the developer clicked on that and Philippe got in. The developer did not click on that link. They reported it. Philippe had to find other ways to get in there. And I know this sounds like a really shitty story, but it gets a lot better. What ended up happening is that Philippe kept GitLhub running because he was like, I'll use this in the future. Someone on Twitter posted their open source project, but they misspelt it and used GitLhub. And because it was a clone, it actually displayed all the correct information and no one was aware. Then the search engine started indexing it because that was the first link, and then it started being displayed. And Philippe had no idea that this had happened until one day he realized his logs were full and he had 20,000 credentials into GitHub. Now, there's a moment in every pen tester's life where you really debate which direction you want to take. Philippe lives in Dubai now. No. So what can we do to protect this? So when it comes to protecting your source code, the number one thing to do is secrets detection. If someone gains access to your source code, it shouldn't be the end of the world. It should be a little bit of a concern from your intellectual property, but the main concern is with secrets. There's some great secrets detection tools, TruffleHog, GitLeaks. I think GitLeaks is kind of merged with TruffleHog a little bit. GGShield. GGShield is again open source-ish. It's a great tool, but you again need an API and send your data out. And this is kind of like the best way to ensure that you don't have secrets in there. And the best way to use secrets detection is actually, you do need to scan your source code for it, but it's best to have it in as a Git hook on your developers. This isn't foolproof because they can't skip it, obviously, but if I have here some credentials in my file, these are real AWS keys. Quick, take a picture and you can, just kidding. These are honey tokens, but if I try and commit this into here, if you have secrets detection on as a Git hook, what this does is before those secrets have the opportunity to leave, they get picked up in a Git hook and they get blocked. So we can see here that they have AWS keys that are invalid and some AWS keys that are valid that have been picked up on this Git hook and it's blocked it. The reason why this is so much better than scanning it is if secrets make it into your repository, it doesn't matter how long they've been there, they need to be revoked because source code is distributed so widely. So if you're going to implement secrets detection, best to do it before it gets there, but you also need another layer as a fail safe. Now, public service announcement, SAST is not secrets detection. I know that a lot of SaaS tools, and we'll talk about this, do secrets detection, but what SaaS is looking for and what they're meant to be looking for is, if we look on your Git tree here, you're looking at the latest version. You want to scan it. If you have an SQL injection vulnerability down here, no one cares, as long as it's been fixed, right? So SAST isn't concerned about all the history of your project. But when it comes to secrets, if you've got a developer working on their own branch, they commit a secret just to see if something works, right? They're not going to merge it into master. They then remove it, but that secret remains in the history. It remains a threat. You're still able to find that. And that's why secrets detection is different. Secrets detection has to go through that Git tree and uncover secrets in the history. So if you're implementing secrets detection, make sure you implement it that way. All right. Moving along from secrets detection, let's talk about securing our cloud infrastructure. So according to CrowdStrike, we're seeing like nearly 100% increase year over year on cloud exploitation. So this is obviously, a massive threat. So what actually hides in your clouds? What are we looking for? Open ports. Port 22 is notorious, the default port for SSH connections. Excessive account permissions. Something like open S3 buckets. This was a plague a couple of years ago. Everyone's getting briefed for open S3 buckets. Configuration drift. Something like when you have multiple changes that create small little incremental security breaches or security opportunities. And also, we just talked about secrets, but I'm going to mention them again. Secrets in your infrastructure as code files. This has been a massive problem that we've seen when when IAC has come. And there's been a bunch of companies here. Mercedes-Benz had a recent breach because of that in there. I don't quite have time to stick to my time frame to go into all of them. But if we're wanting to secure our cloud, what are the two areas that we're really looking at? CSPM, Cloud Software Posture Management, and CloudSploit is a great open source tool to be able to do this. And IAC scanning, and Checkov is kind of equivalent for this. IAC scanning, infrastructure as code files, we're really looking at trying to scan your infrastructure as code and making sure that there's no misconfigurations in there. And then also your CSPM, checking into your cloud accounts. This will connect with your cloud accounts and make sure you don't have any misconfigurations within them. And coming on to kind of the last of those 4 segments, securing your actual application. And what does that entail and does that mean? So, if you're familiar with the OWASP top 10, which I'm sure most of you will be, these will probably all seem pretty familiar. Broken access control, business logic failures, cryptographic failures, and injection. These are all things that become threats when our application is running. So if we have a look at some examples from this, I'll talk about Optus in a minute, but business logic fails. Coinbase had one where you could essentially change your Bitcoin or you'll change your Ethereum or any other coin to Bitcoin. They didn't actually check when you made an exchange what coin you were actually sending, so you could manipulate it. Cryptographic failures, we had massive breaches because of unencrypted database here, and injection. Which I'll talk about in a minute, which remains a massive vulnerability and a massive threat to us, even though it's been around since the 90s. But I first want to talk about Optus, because this was a pretty major breach. So if you haven't lived in Australia for a while, you probably won't know what Optus is. But Optus is Australia's second largest telecom provider. And Optus had a breach that exposed the personal data of half of all the people in Australia. So about as bad as it gets. And really how this happened is that Optus had a API endpoint that was unprotected. And really this was how you could retrieve customer information. Now, an unprotected API endpoint shouldn't be the absolute end of the world, because to be able to get information, you needed your user ID. And if you're using high entry strings as user IDs that aren't sequential, it should be very difficult to try and randomly get someone's ID from their accounts. But I'm sure based on that statement, you can guess what the next vulnerability was, is that Optus used sequential ID numbers for every single person, which meant you could just skip through every single person in the next system, and next thing you know, you have 10 million, you have the personal information of 10 million people in Australia. So this is broken access control, and definitely one of the worst cases of that we've seen. Now, injection remains a long time. OWASP, this was SQL injection specifically, but there's lots of different types of injection. And just recently, I did a little bit of research into how prominent injection vulnerabilities still are today. Do we actually care? And what we've found is that if we look at the open source databases that we have available, like the GitHub advisory, we'll see that in 2024, SQL injection accounts for almost 7% of all vulnerabilities found in open source projects, and command injection accounts for 7%. And in closed source projects, it's 10% and 5%. So around about 14% of vulnerabilities in open source projects and 16% in closed are just command and SQL injection vulnerabilities. That's a huge portion. So injection vulnerabilities, whilst it's been around for ages, whilst we all know about SQL injection, and whilst we all know how to fix it, it still seems to be a massive problem for us. So how can we solve this? There's something called an in-app firewall. Zen is an open source project that we make, Aikido, which is kind of like a WAF. If you're familiar with web application firewall, then an in-app firewall is similar, but it sits inside your application and it can understand the requests that are being made. So if someone does an injection vulnerability, it can block it. So it's runtime protection. And there's been a lot of trend about shifting left. Well, this is kind of going the other way. This is kind of a shift right vulnerability. And I always say that this one's a critical one to implement because you can solve a lot of problems whilst you're getting your security up to date by implementing something like this. SAST Static application security testing, this is something that looks through your code. There's lots of tools for this. SemGrip is one that gives broad coverage into a lot of languages, but there's also language-specific ones, Bandit for Python, GoSec, Brakeman for Ruby, and of course Dast, which is something like Nuclear, or ZAP, which used to be an OWASP project, but it's not. I'm running out of time, so I won't do any demos of these tools, but they're very easy to set up, and we can see how they all work. But these are kind of some of the tools that we should absolutely be using to do this. Now, I've just rattled off a whole bunch of tools, and everyone's very confused. And how does any of this actually all fit together? How do you do this? You don't sit there and run scans every day. We have to have some way of being able to fit this. And in case you're wondering, yes, this is definitely an AI-generated image. But they're getting better, I gotta say. So we kind of need a way to do this. So I mentioned before with secret detection that I liked having it on the developer environment, something like a Git hook. So having SAST and secret detection on the developer environment is always fantastic because it's the easiest way to resolve these problems before it gets elevated, and developers can handle them themselves. But it's not foolproof because we do need to make sure that none of those actually pass through. So we also need them in our CI/CD pipeline. And the CI/CD pipeline is absolutely key to be able to configure anything when it comes to open source tool, because we need a centralized way to trigger everything, to run everything. So if you want to have an open source kind of security, your CI/CD pipeline is absolutely going to be your best friend for this. And then obviously having our in-app firewall over there in our runtime. And then the final stage that we need to fit all this together is to kind of make sure that we can send this information somewhere, so that we can take all of the security tools that we have and we can send them. And this here into a dashboard, I forgot to put it up here. I was meant to put Grafana up there as an option. So just imagine that Grafana is up there. But Grafana dashboards are great for that. So we can take our information from our CI/CD pipeline and we can display it somewhere. And this is kind of absolutely key into making sure that we can do it. So I think now comes, we have an idea of what to do. There is an investment when it comes to open source tool, but the best thing about it is we don't need to do all of this at once. It's all overwhelming, but we can start with one tool at a time and we can implement it in clear stages. But a question that I think a lot of people are probably wondering now is, are open source tools as good as commercial tools? And I think we can absolutely say yes, they are at detection. Commercial tools add some other elements to it, but we can also touch on those ourselves with dashboards, with further findings. But don't think that just because a tool is open source, that is actually worse than the commercial tools, because even though we tell you and other people don't, a lot of tools use the open source as their core, not because they're lazy, but just because it's good. The tools are good and solid. So when it comes to being able to kind of build out a security platform, you should absolutely consider open source. And the reason, as I said before, is kind of why I like to say that as someone from a commercial vendor, is that if you're outgrown the need for open source, or you don't want to make the continued investment to it, then you become a really good prospect for us. So it's not something that I think people should shy away from in trying to encourage people to go down the open source route, because if it works, then I don't think that you ever would have been a customer in the first place, because I think that the tools can do a great job. So just to finish up, like, why would you want to choose open source over anything else? Initial investment, community-driven, flexibility, and getting that proof of concept. If you're struggling to get buy-in for purchasing developer tools to sponsor a Formula 1 team by proxy, then you can use open source tools to try and kind of prove the problems, understand the environment, and make your way there. And you can also build out a fantastic system step by step and extend out that investment so you don't have to sign up and sell your left kidney immediately. The cons: yes, you are going to have to do some maintenance. There is going to be limited support. There are limited features out the back, and it is going to cost some engineering time. But ultimately, you don't need to make all of those decisions immediately up front. You can just get started, and I think that's what the power comes in from choosing open source. So that's all I had for you today. I hope you found some interest from that, and I hope you'll consider maybe testing out some of the open source tools as you go. And if you want to follow me, you can follow me on LinkedIn, it's probably the best place, and I'm everywhere under the handle Advocate Max. So thank you all for listening.